All right, 1.7, modeling with functions. I think this is the section last year that I, legitimately gave them a problem in class. They did it for homework. We went over how to do it in class. We did it on the review. On the test, I changed the numbers, and they all gave me the answer from the homework problem. I was like, wow, that's not the answer. They were like, what? But in class, I said, oh, hold on. On the test, it wasn't. So, then on the exam, I gave them different numbers, and they still got it wrong. It was pretty funny. All right. Functions from formulas. There's not really a lot of notes here, so I'm just going to do some examples. Write the area of a circle as a function of its, first one we'll do is radius r. So what's the area of a circle? Okay, so for that one, since the normal area formula is already has r in it, we can just write that one. A is equal to pi r squared. Functions. All right, let's do area as a function of its diameter d. So what would that area be? A equals pi times d over 2 squared. Okay, or you could also write it this way. This way is acceptable, but you could also write it as pi over 4 times d squared. Okay, those are the exact same thing. So it doesn't matter which one you write. They both mean the same thing. All right, and then let's do it as a function of circumference c. What would I need to do for that one? What's the formula for circumference? 2 pi r. Okay, doesn't matter what order it's in, but I just always do 2 pi r because you always want the numbers in front. So then we need to solve for r. So if we solve for r, what do we get? I'm solving for r here in this equation. Okay, and now what do I need to do this as area? A equals pi times c over 2 pi squared. Okay, and then that simplifies into pi c squared over 4 pi squared, which goes down to c squared over 4 pi. All right, so this next type is going to be a very common type of problem you will see I can pretty much guarantee a problem similar to this one will be on your test. Okay, the quiz isn't going to be on this section, but it will be on the test. So, alright. We're looking, or this is going to be a max value problem. Okay, we also could do it for a minimum value, but this one's going to be for a max value. So basically we have a square of side x inches is cut out of each corner of an 8-inch by 15-inch piece of cardboard. And the sides are folded up to form an open top box. Okay, so I'll draw out for you what this looks like. I'm going to draw it over here. Okay, so basically we're given an 8 by 15-inch. This is not really proportional, but basically a piece of cardboard. Okay, it says that there is a square of side x inches cut out of each corner. So basically we're cutting all this out here. Okay, and this is side x. Okay, all of those are x. Okay, and then basically it'll fold up then to form a box. I never liked word problems, but they always sent me to reasoning in the Math Olympics, and I always did better in that than computation, which made no sense. It was like every other year for me. We go up through 8th grade. Oh, 5th, I think. Anyways, okay, that's not a great box, but it's a box nonetheless. Alright, so we want to write the volume of a box as a function of x, okay? So there's a couple things we should take note of here, okay? Basically, we have a base that has a width of, so this width here is 8 minus 2x, okay? Because there's an x on both sides here, and we know this total side length is 8, okay? So the width is 8 minus 2x. Okay, now similar for length, okay, both ends are x, okay. We know that the whole thing is 15, so the length is going to be 15 minus 2x. And we know that the height of the box, because we took out an x, here, because we've taken out the square corners, we know the height is going to be x when we fold the sides up on the box. Okay? Okay? So we want volume of a rectangular box. What in general is volume? What? Yes, length times width times height. Okay? Okay? Length times width times height. So now when I do this, okay, I literally just put all this stuff out here. So V is equal to 15 minus 2x times 8 minus 2x times x. Okay? And that's all you have to do for write the volume as a function of x. Alright, so now you need your calculator. Nope. Okay, I need to know now what the max volume would be for this, okay? Because I want to ultimately find x. I want to know what this size of the square being cut out is. Okay, so I want to find the max volume. So basically, what can I take out of the corners of each one to give me the biggest size box that I can have? So that's what I'm going to find the max volume, okay? And we're going to do that using our calculator. So you're going to plug this equation into y equals. Stat people, make sure you turn off your stat plot. Yeah. But when you do that, does it fit on your calculator? No. I would do zoom. I think there's like a fit option. Yeah, zoom fit is zoom 0. Zoom 0. Alright, so now we're going to use the second and then trace. Okay, and then we're going to use the max option. So we need to go on the left side. So I would take it all the way down to like this left part of your curve over here, and then all the way up to the right part of it. Yeah. Yeah. Hold on a second. Yeah, but mine didn't give me the right answer, so hold on a second. Hold on a second. Why is this not working? Okay. There we go. Okay. Go change your window to basically this. I can actually take, I don't really need this to be, -5, and I'm just going to go out to 10 here. That'll make it a little nicer. Hit window. Gray button at the top. No, don't hit zoom 0. That erases everything you just did. Then go back and do this. If you have this screen still when you're done, hit graph. Then you're going to have to change it to say that. When you hit window, you have to type in that stuff. You have to change your window. Now use your trace option and find that second trace and find the max value. Second trace maximum. Left side, right side. Yeah. Did everybody get this? And then 90.74. Okay, so let me show you. Okay, so when it asks for the max value, we're looking at the Y value. So our max volume is 90.74 inches squared. Okay, and that's just from the calculator. Okay, then it's the last thing we want to know is what what side length should the squares have that are cut out. Alright, so hold on, I need to get back to what I had before because I accidentally hit a button. Huh? Yeah, let me put this back up there to do it. Okay, so when you want to know then what value is being cut out, okay, you found the max volume, that's the Y value. Okay, so that was this Y value here is your max volume. Now, what needs to be cut out to make that true? 1.66 inches, or 1.67 inches. Okay, you're not cutting volume, you're cutting sides of the box to give it the max volume. So if we actually had an 8-inch by 15-inch piece of cardboard and we were to cut that out, that is where we would have the max volume. Okay, you could cut out any size you want and create a box, but we wanted the max volume. Okay, in this case. Okay, you could do the same thing with a piece of paper. Could cut out corners of your paper to figure out then when I fold it up and create a box, what size would give me the biggest box out of a piece of paper. Because this is an 8.5 by 11 piece of paper. Yes, if it does not have a top. It's an open box. Exactly. Okay, the more, obviously we're going to do more so that, will help, but. Alright, Alright, let's look at a couple little examples here and then we'll stop. Huh? Yeah, I'm going to do actual book problems now. Alright, number 2 says a number x is, increased by 5 and then tripled. And I want to write a formula for this. Tripled, not cubed. So, yeah, so we have x plus 5, okay, and then the whole thing is tripled, so that would be our formula. Okay. For 4 more than 5% of a number x. What do we think this one is? 0.5? 0.05x and then plus 4. Okay, and the reason being that it's not 0.5 times x plus 4 is because it says 4 more than 5% of x. Okay, so we add 4 at the end. So it's really important. It's really important to pay attention to the order that it's asking you to do stuff with these kind of problems. Do y'all remember what the altitude of a triangle is? Yeah, basically. Basically, it's height. Alright. The area of a triangle whose altitude than the base length x. So, first and foremost, what is the area of a triangle? Okay, 1/2 base times height. Okay, altitude is basically its height. So, based on that, what would my area of this triangle be? Okay, 1/2 times the base, so the base is x. And then what is the height or altitude? Everything in the same variable. X plus 2, but yes. Okay, it's 2 more than the base, that's x plus 2. Okay, it's our base plus 2. Okay, and you can obviously just leave it this way. You don't need to, like, combine things together. Just leave it as, yep, so it's 2 more than. So the height said it was 2 more than the base, okay? So that's why we need to use whatever we were given for base and then add the 2 to it. All right, income after a 3% drop in the current income of X dollars. So basically, if you took a 3% pay cut, what would your income be now? Sort of. If I take away 3% of 100%, what am I left with? Okay, so this one would literally just be 0.97x. Okay, that would be what your income is now. Okay, your income before would have been basically 1 times x, okay, but a 3% drop, we have to take away that 3%, leaving us with 97% of that original income, which was x, so now we have 0.97x. Okay? I think that's good. So, or right now, because there's still like 15 minutes left. No. Technically, it'll all be due at the end of the section, but yeah. So, if you really don't want to work on it right now, you can work on something else, but it will all be due together. And I will obviously add more on Monday.